Today, we're going to dive deep, and I mean literally deep, into a really critical piece of technology that makes our modern world run. It's called well perforating, and it's all about using controlled explosions miles underground to unlock the energy reserves that power our lives.
So to really get what perforating is all about, you first have to understand the massive challenge it was designed to solve. You can think of it as the billion-dollar puncture problem.
Okay, imagine this. You've just spent millions, maybe tens of millions of dollars, drilling a well that goes thousands of feet into the earth. You've hit the jackpot, a reservoir of oil or gas. You are right there. But here's the catch. You're completely sealed off from it by solid steel and cement. So the big question is, how do you open the door?
See, a modern well isn't just an open hole in the ground. It's heavily fortified. For safety and stability, it's lined with this fixed steel pipe called a casing, and then that casing is cemented into place. What you end up with is a totally sealed tube, which is great for control, but it also completely isolates you from the very rock you're trying to get into.
The solution is both ingenious and incredibly powerful. It's called shaped charge perforating. This is where engineers use these very precisely designed explosives to blast clean, deep tunnels right through that steel and cement. It creates a perfect, direct pathway for oil and gas to finally flow from the rock and into the well. But a technology this advanced doesn't just pop up overnight. In the early days, engineers were stuck with a pretty big dilemma. They had two competing methods, and honestly, each one had some serious downsides.
So on one hand, you had through tubing perforating. For this, you could lower these small explosive guns down on a simple cable. It was pretty flexible, sure, but you could only perforate short little sections at a time. On the other hand, you had casing guns. Now these things were big and powerful, but the catch was you had to use them before you put the main production pipe in, which was a huge pain and super inefficient. So you had to choose. Did you want flexibility or did you want power? You couldn't have both.
And this really just nails it, doesn't it? This was the problem everyone was trying to solve. The industry was desperate for a breakthrough, some way to get the best of both worlds. They needed the power of those big guns, but with the smart, flexible operations of the smaller systems.
And that breakthrough finally came. It was called Tubing Conveyed Perforating, or TCP for short. And this system was just brilliant. It elegantly solved that old problem by combining the strengths of both methods into one super effective package.
TCP brought some huge advantages to the table. First, you could finally use those large, powerful guns after the main production pipe was already in the well. This meant you could perforate thousands of feet in just one single trip. Second, it allowed for something called underbalanced firing. This is so cool. Basically, you intentionally lower the pressure inside the well right before you detonate. The moment those charges fire, the higher pressure from the surrounding rock acts like a power washer, instantly blasting all the debris out of the brand new tunnels. The system literally cleans itself. It's an amazing design.
Of course, having all these powerful explosives thousands of feet underground brings up a pretty important question. How in the world do you set them off safely and at the exact right moment? Well, this is where the real magic of the technology comes in, the firing heads.
Let's take a look at one type, the hydraulic delay firing head. You can think of it like a very sophisticated high-pressure kitchen timer. Up on the surface, engineers increase the pressure inside the pipe. That pressure snaps a specific set of pins inside the tool, which starts a countdown. This delay gives them just enough time to get the well pressure exactly right for that perfect underbalanced condition, and then, boom, the gun fires right on schedule.
Another really clever design is the differential pressure head. This one doesn't just fire because of high pressure alone. No, it only activates when it detects a very specific difference in pressure between the inside of the pipe and the outside. You can really see how focused they are on safety here. It even has a spring that physically locks the whole mechanism if the overall pressures are too low, which helps prevent it from ever going off by accident.
But if you want to talk about the absolute safest system out there, it has to be the trigger charge firing system. With this method, the main gun assembly goes into the well without its primary detonator. It's completely inert. Only when everything is perfectly in place, just moments before they're ready to fire, do they run a small trigger charge down on the wireline and plug it in. It's like only putting the firing pin into a device at the very last second. It just dramatically cuts down the risk.
So we've walked through the problem, the evolution of the solutions, and the details of the technology. But let's pull back for a second. Why does all of this really matter? What kind of impact has tubing conveyed perforating actually had on the world?
Well, the impact has been absolutely massive. Efficiency went through the roof because you could suddenly do way more work in a lot less time.
Safety improved dramatically thanks to these advanced multi-step triggers. And most importantly, the productivity of the wells shot up because those cleaner, deeper tunnels created by TCP just allowed for a much better flow of oil and gas.
And if you want to boil it all down, it really comes down to the number one, a single run. What used to take days and multiple trips in and out of the well could now be done in one single, efficient go. In an industry where one day of rig time can cost hundreds of thousands of dollars, that kind of efficiency isn't just an improvement, it's a total game changer.
So, the next time you flip a light switch or fill up your car, just take a second to remember this incredible, invisible technology at work, miles beneath our feet. It kind of makes you wonder, right? What other complex feats of engineering, hidden just out of sight, are we all taking for granted every single day?